Looking at our constitutional isomers of alkenes, please keep in mind that these would also apply to our alkynes. Alkenes, because they have a double bond, and that double bond also needs a locant or a carbon number associated with it, the movement of the double bond will also form another constitutional isomer. So there's two different ways in which to make a constitutional isomer with alkenes: moving the placement of the double bond and or increasing the branching of the parent chain. Looking at constitutional isomers of acyclic butene. Butene will have a molecular formula of C4H8. When we are making our constitutional isomers, we want to make the longest parent chain possible, and because this is an alkene, I suggest putting the double bond on the first carbon. So because of the placement of that double bond, we get 1 butene. Because the double bond can be moved to a different carbon and make a new name, therefore a new isomer, the movement of that double bond to, let's say, starting on carbon 2 will change the position of that double bond. So when we have 1-butene, it has a particular shape and it will have particular properties. But when that double bond gets moved to carbon 2, so between carbon 2 and 3, it changes the shape of this molecule, and that will also change the physical and chemical properties, making it an isomer of the 1-butene. In addition, we can repeat what we did with our alkanes. If we take that terminal carbon group that's furthest from the double bond and we can move it interior, we will be reducing that parent chain by 1, creating a 3-carbon parent chain, and this 4th carbon will then need to move interior. There is only 1 carbon available for that interior in which to add that branch to, so that will be on carbon 2. We will finish out with our hydrogens. Therefore, we now have a propene due to the longest parent chain. We have a methyl group on carbon 2, so we have 2-methyl propene. We do not need to put the 1 for the double bond of that propene because no matter what, with only 3 carbons, that double bond is on carbon number 1. But if it helps you to maintain your structure, you can write 2-methyl 1-propene. To show this with our models, here we have that double bond. So I have a terminal carbon that is furthest away that I can remove to go down to that new parent chain. The middle or interior carbon is the only one in which we can substitute the methyl group on. We have to have a hydrogen available to allow substitution to occur. So I take that hydrogen off to create that bonding site for the new methyl group. And then that hydrogen has been moved over to the new terminal carbon, creating the new structure.